Imagine a bridge. Not just any bridge, but a marvel of modern engineering. A shimmering ribbon of steel and concrete, stretching nearly a mile across the water, the third longest suspension bridge in the world. It was a symbol of human ambition, a testament to our ability to conquer nature. Now, imagine watching that same bridge twist and ripple like it was made of fabric, literally dancing itself to death in a gentle breeze. How could this happen? How could something so solid, so monumental, fail so spectacularly? This isn't a scene from a disaster movie. This is the true and truly bizarre story of the Tacoma Narrows Bridge. Welcome back to our channel, where we explore the triumphs and failures of human ingenuity. Today, we're diving into the incredible tale of Galloping Gertie, a bridge that taught engineers a terrifying and invaluable lesson. Our story begins in the late 1930s in Washington state. The Puget Sound was a major obstacle, separating the city of Tacoma from the Kitsap Peninsula. A bridge was desperately needed to connect these communities and foster economic growth. The man tasked with designing this ambitious project was Leon Moisseiff, a renowned and respected engineer. He was a leading proponent of a theory that favored slender, elegant, and flexible bridge designs. His idea was that a lighter, more graceful bridge would not only be cheaper to build, but also more aesthetically pleasing. Using deep, heavy trusses for stiffness was seen as old-fashioned. Moisseiff's design for the Tacoma Narrows Bridge was the epitome of this new philosophy. A long, narrow, and incredibly sleek structure. Construction began in September 1938. As the bridge took shape over the Tacoma Narrows Strait, it was hailed as a masterpiece. Its two tall towers and gracefully draped cables created a stunning silhouette against the sky. On July 1, 1940, the bridge opened to great fanfare. It was a proud moment for Tacoma and a triumph for modern engineering. But almost immediately, something was off. Even during construction, workers noticed that the bridge deck had an unsettling tendency to move. On windy days, it wouldn't just sway. It would undulate, rising and falling in waves that could be several feet high. It was like riding a roller coaster. This motion earned the bridge its famous nickname, Galloping Gertie. For the 4 months it was open, it became a local tourist attraction. People would drive from miles around just to experience the thrilling, stomach-churning ride across the undulating deck. It was a novelty, a fun quirk of the new bridge. No one considered it a real danger. After all, it was designed by one of the world's best engineers. It was made of steel and concrete. It was safe, right? The morning of November 7th, 1940, started like any other. The wind was blowing through the Narrows, but at a modest 42 miles per hour strong, but nothing the bridge hadn't handled before. But on this day, something was different. The usual up and down galloping motion began, but then it changed. The bridge started twisting. The entire roadway began to tilt violently from side to side, one edge rising high into the air, while the other plunged downwards. A local camera shop owner named Barney Elliott and a University of Washington professor, Frederick Burt Farquharson, who had been studying the bridge's movements, were there to witness it. Their incredible footage is the reason we can see this disaster unfold today. The twisting became more and more extreme. The deck tilted at angles of up to 45 degrees. The steel groaned and the concrete cracked. The only car left on the bridge belonged to a man named Leonard Coatsworth. He had been forced to abandon it when the motion became too violent. Inside the car was his 3-legged Cocker Spaniel, Tubby. Tragically, the dog was too terrified to leave the vehicle, and attempts to rescue him failed as the bridge's movements grew more frantic. Then, at around 11 a.m., the end came. With a deafening roar, a huge 600-foot section of the center span tore loose from its suspender cables. It twisted over, plunged into the water below, and sent up a massive spray. Section by section, the rest of the main deck followed, collapsing into the cold waters of the Puget Sound. In a matter of hours, the multi-million-dollar marvel of engineering was a mangled wreck. Miraculously, the only fatality was poor Tubby, the dog. The monumental failure had been captured on film for the entire world to see. So, what went wrong? How could a bridge designed to withstand high winds be destroyed by a relatively moderate breeze? The answer lies in a phenomenon that engineers at the time didn't fully understand: aeroelastic flutter. Let's break that down. Think about a flag flapping in the wind. The wind flows over the fabric, creating areas of high and low pressure. This pressure difference makes the flag move. But as it moves, it changes the way the wind flows over it, which in turn changes the pressure, causing it to move again. This creates a self-sustaining cycle of movement or oscillation. The Tacoma Narrows Bridge was, in essence, a giant flat ribbon of steel. Its design, so celebrated for its slender elegance, was its fatal flaw. The solid plate girders on the sides of the deck didn't allow wind to pass through. Instead, the wind had to go over and under. As the wind blew across the deck, it created swirling vortices of air, like tiny whirlpools. On that fateful day, the frequency of these vortices just happened to match the bridge's natural twisting frequency. This is called resonance. Every push from the wind added more energy to the bridge's twisting motion, just like pushing a child on a swing at the right moment makes them go higher and higher. The twisting motion grew uncontrollably, amplified with every gust, until the structural forces became too great. The steel and concrete simply couldn't take the stress anymore, and the bridge tore itself apart. It wasn't the strength of the wind that destroyed the bridge, it was the rhythm. The collapse of Galloping Gertie was a shocking and humbling event for the engineering community. It was a wake-up call that sent ripples through the profession worldwide. The footage was studied intently in engineering schools for decades. The failure forced a complete reevaluation of how bridges were designed, particularly long-span suspension bridges. Engineers realized that aerodynamics were just as important as structural strength. They couldn't just build a bridge to be strong. They had to build it to be stable in the wind. This led to a revolution in bridge design. Future bridges like the Verrazano Narrows in New York or the Akashi Kakyo in Japan were built with deep, stiffening trusses that allowed wind to pass through, disrupting the formation of those destructive vortices. Wind tunnel testing, which was considered a minor part of the process before 1940, became a mandatory and critical step in designing any major structure. The lessons learned from Gertie's demise directly influenced the design of every major bridge built since. The replacement Tacoma Narrows Bridge, which opened in 1950 right next to the ruins of the original, was a much more robust, truss-stiffened design. Still stands today, a testament to the lessons learned. The story of Galloping Gertie is more than just a tale of a collapsed bridge. It's a powerful reminder that innovation always carries risk. It shows us that our understanding of the world is constantly evolving, and that sometimes we learn our most important lessons from our greatest failures. The ambition to build something beautiful and elegant led to a spectacular disaster. But from that disaster came a new era of knowledge that has made countless bridges around the world safer for all of us. It was a failure that ultimately pushed engineering forward. Thanks for joining us on this deep dive into one of history's most famous engineering disasters. What do you think is the most surprising part of this story? Let us know in the comments below. And be sure to subscribe, because next time, we're exploring the incredible story behind the Panama Canal, a project that succeeded against all odds. You won't want to miss it. See you then.